Hi, and welcome to the 9th day of Keysight University Live. I'm Daniel Bogdanoff, live from Colorado Springs, and I'm your host for this event. Thank you so much for joining us. I have been looking forward to this stream for a while. It should be a really good one. Each event day, we have an interview with a technical expert. Today, we get to sit down with Joel Dunsmore, who is arguably one of the world's foremost VNA designers, and honestly, it's just a delightful interview. He's also answering questions in chat if you're here live. We'll have that interview in a moment, and then we'll draw today's test gear winners and do some live Q&A. First, let's make sure everyone's literally on the same page. If you go to today's event page, you'll see the live stream that's happening right now if you're watching it live, and we're so excited to have you live. There is chat on the right side of the video as well, so you can interact with Joel Dunsmore here in chat answering questions. How often do you get to live chat with a VNA pro like that? A couple buttons here you should check out. One, if you haven't clicked it yet today, is Get My Daily Entry, and the other is Give Me Exclusive Access. That basically keeps you up to date with some of the special things we have planned after this event is over, just for people who sign up for this event. And of course, the video, the YouTube video for today, we looked at the basics of using the Smith chart, and we measured the RF performance of an antenna using a really fancy VNA. And if you want to see the VNAs that we used in that video and that we're talking about today with Joel, you can check out the Network Analyzer products catalog on the lower right. And if you want to learn more about using VNAs, I highly recommend you check out this VNA Fundamentals class. Matt Campbell hosts it. It was an awesome course. It's over on the Keysight University page. There's a ton of great VNA information over there if you want to start getting your hands dirty and learning more about the RF side of the fence or how to use VNAs specifically. So that's essentially our day. We have the interview, we'll draw some winners, and do some live Q&A. Without further ado, let's jump right into the interview with Joel Dunsmore. So Dr. Joel Dunsmore is one of the principal designers for Keysight's vector network analyzers, starting in 1980 on the HP 8753. Since 2007, working on the PNAX, he's been devoted to bringing new measurement science to the world of component tests, and many of his ideas have been patented. He has 33 patents, and these form the core of the measurement applications on the PNAX. Joel, I'm so excited to have you here. Thank you so much for coming on.
Thanks for inviting me.
So I heard you mention in conversation a while back that your life's goal has been to make the PNA network analyzer the one-stop shop for test equipment. I myself started with oscilloscopes and kind of have felt that the oscilloscope could go the same route. So my question is, how dare you, and what do you have to say for yourself?
Well, an oscilloscope is okay for a college student in a sophomore college class. But if you want accuracy and dynamic range and full performance, then clearly a vector network analyzer is the go-to tool, especially if you're going to build on it great castles and structures that make it I like to say, the one ring to rule them all.
Sure. So what about a VNA makes it, poised to become that, one-stop shop, especially for RF and microwave tests?
So it's particularly in the area of component tests. So I'll kind of separate component test and signal testing. And oscilloscopes are really dedicated to signal testing and spectrum analyzers as well. But for component testing, for the bits and pieces that make up your radios and satellites and microwave ovens, those have inputs and outputs, and the synchronized nature of a vector network analyzer, the way we do it in Keysight, makes it able to get a really excellent result in measuring components.
That makes sense. And when you say the way we do it, I'm sure we're going to get into that more. But one question I'd like to start with in that vein is it even like cost effective to go after that, or is it better just to have separate boxes that do separate things?
So if you have one thing to measure, I want to measure noise figure and nothing else, or I just want to measure the harmonics of a coming out of an amplifier, then the standalone test equipment is probably the most cost effective. But almost never do you see someone wanting to measure just one thing. You need to measure noise figure, but you also need to measure gain. So you're going to have a network analyzer to measure the gain and a noise figure analyzer to measure the noise figure. You're going to want the gain and you're going to want the harmonics. So now you have to have a spectrum analyzer and a network analyzer. And as soon as you move into either a production test system or, like I have set up, an RD test system where you want to be able to remotely control and switch between measurements. Then you have to have a switching test set and all the calibration and control of that. And pretty soon, well, not pretty soon, right away, the expense of multiple pieces of equipment and test sets will far exceed the cost of the VNA.
That makes sense. So you would definitely want to have some sort of the cost is more than just the boxes. There's the engineering cost, there's the time cost, calibration cost, especially maybe in a manufacturing environment.
Well, there's certainly those extra costs that we use those costs to push the sales over the top, so to speak, when people are really complaining about it. But in fact, if you just look at the raw cost of the instruments, you take the example I used is the classic mixer measurement. You need a source or two sources and a spectrum analyzer. By the time you add those up, you're already more expensive than a VNA. So most of the time, particularly with the PNA or PNAX, when we go in with the economic argument that this is the most cost-effective way for you to get the total measurement scenario that you want.
That makes sense. And part of the work that you've done has been bringing some of those, I think I came across the phrase image-free spectrum analyzer, bringing those capabilities into a VNA. Can you speak to that a little bit?
Yes. So the thing about VNAs is they really changed in the last 40 years. So I started with the HP 8753. It was the first integrated RF network analyzer, and I was the RF circuit designer on that. And back then, circuits were hard to do, and you had lots of little bits and pieces. It got very expensive very fast. So a network analyzer didn't need a high-quality source, so we basically did the lowest cost source we could. The receivers were narrow band, and again, because the technology really wasn't available, it would take big boxes of equipment to do what we do today. In the PNAX, the sources and receivers really look like the sources in standalone analog sources and the receivers in the spectrum analyzer. So there's not a great deal of difference in the hardware. And the work that I've been doing is taking the hardware we have and figuring out how can we utilize it to make these measurements. So the spectrum analyzer is a really good example of something that there are other spectrum analyzers that have almost the same block diagram, particularly in the millimeter wave. And we knew in the network analyzer, we had to do a really good job of solving some of the problems with these non-image free spectrum analyzers. So we do it all algorithmically with, that means we use software to do it. And we basically tried to do a better job than anyone had done before in making a high quality measurement with the hardware we have.
What has triggered the change from cheapest source to this high-end microwave source?
So it's interesting that I would say it comes from our Keysight labs is really the heart and soul of that. A really good example is the new sources that we have in the PNAX. We introduced them in September of last year. It was one good thing to come out of 2020. These are the new DDS sources, and they're based on a chipset that's a custom chipset out of Keysight labs. So it allows us to put the high quality analog source of like a PSG or an MXG, 4 of them inside a PNA because of the size and cost reduction. And also the quality of them has gotten better and better. It's using some really unique technology that allows us to have these very pure, low phase noise, high quality, low spur synthesizers. Those are going to be needed if you're going to do things like spectrum analysis and phase noise measurements.
Yeah, that makes a ton of sense. Is this the indium phosphide plant stuff that we do? Same group?
I'm not going to go into the details of what we have inside of them. We have lots of indium phosphide, lots of gallium arsenide, and that stuff we kind of keep a little proprietary.
That makes sense. I know I run into that a lot with the UXR chips. We do some out of that group as well.
I will tell you, it was the same team that did the UXR digitizer that did our new synthesizer.
That makes sense. That's pretty cool. So shifting gears a little bit, I wanted to ask you, what are your top 3 VNAs of all time? Not best performance, but most. You've been around VNAs for as long as anybody. What are the most nostalgic or most? What do you feel the most fond of? If you had to name 3 of them.
Well, of course, I'm fond of saying the world's best network analyzer was the HP 8753. There's no question. that is like a firstborn child to me. The the HP 8510 really was the, breakthrough new generation of analyzers, and we still have customers that use them today, 45 years after it was introduced or developed. And of course, the P&AX is really now, it's like the combination of a Maserati and a Lamborghini with a nice Ford F-250 Super Duty.
So it's a workhorse with an LS swap or something like that.
It is the workhorse of all things. It can do anything, and if it can't do something you need to do, just tell us, because we probably didn't know about it. We'll put it
Fair
in.
enough. And you called that out. You said you're not just saying that. You really mean that. If there's things that people are trying to do, what's the best way to give feedback?
So if you go down, you can, of course, go through your Keysight representatives, but of course, you can just contact me if you have something that you think needs to be inside of the analyzer. We'll put it in. And I will tell you, if you go down the list of software and hardware options, maybe a third of them are direct results of customers asking us, can you solve this problem? And we go and noodle on it a bit and resolve the problem with a new software app. And of course, everybody gets to pay us for that.
Sure.
My favorite example of that was at a large satellite customer in the UK. Their satellites don't have a 10 megahertz reference. Apparently, you can't hook a BNC cable to a satellite while it's whizzing around the Earth. So all of our measurement techniques relied on having 10 megahertz reference to measure their frequency converters. And they said, you got to solve this with something they called an embedded LO. So we showed up there with our embedded LO software that solved the problem. With one exception, we solved it by looking at the first point of the sweep and figuring out what their local oscillator was. When we got there, it didn't work at all, because the first point of their sweep was in the stop band of their filter. We couldn't see any signal. So I had a software engineer with me, and I said, is there any way you can hack the code to go to the middle point? And he goes, yeah, I think I can get that done. He had his laptop with the full code there. So he said, great, we're going to the pub for lunch. You stay in the high bay with his bunny suit on. And when we get back, send us a text when you got it working, and we'll come back. So that was actually a really good result, and we got an excellent product out of that. And
yeah, that sounds like a win-win for everyone but the R&D engineer. I would be remiss. I set this up. I meant to open the interview with it, but I don't just have a book here for fun. It has your name on the front of it. So you have literally written the book on VNAs.
Did it twice, in fact. That's the second edition that you have there. The first edition was back in 2012, and it was all CW measurements and swept frequency measurements. You can tell from the front cover there, we're now doing modulated measurements with the VNAs. And so I had to put a wideband QPSK signal on there.
Have there been any surprises, having written a book, especially in 2012? Have there been any surprises for you? People come up and are like, oh, I read your book, that sort of thing? Or has it been kind of business as usual?
Well, of course, it didn't take very long for someone to come up and say, hey, I read your book and I found a mistake on page 23. So I kept one book with me, writing down all the mistakes that I had made. I think every time I read the book, I catch half the mistakes, but I don't know how many are left. I don't know how many I started with. So it's kind of diminishing returns. I'd say that was one of the surprises is how easy it is to make a mistake in something like that. The other thing is a lot of people really didn't, in the book, I go into excruciating detail of how we do things, how we define things. I settled a few scores here at work because we often had some discussions about, what's the right way to define this term or that term. And we use it internally, but sometimes it isn't well defined externally. So now I can say, it's documented. It's fully documented, page 225.
So do you want to publicly call out, not an individual, but a term or a topic that you're especially proud of?
Well, there could be the corrected power measurement would be one of the ones that in particular we had some difficulties. Match corrected power measurements was one of the things that we had difficulty achieving consensus on.
Fair enough. And it has to, yeah.
But now it's settled.
Okay. Well, it's in print. It's official. What are traps that people run into as they're getting started with VNAs? What do they miss? What do they not know?
Oh, that's a great question. The first thing that people think about when they think about, oh, I'm going to make a measurement with a VNA, is they think I'm going to calibrate. Then I'll be able to make my measurement. And in my book, I go through the 6 steps of making a measurement. And calibration doesn't come till quite late. You really need to set up your measurement and optimize your measurement. Make sure your device is working the way you think it is before you start your calibration. And a lot of times you'll find that it's not on the frequency you thought it was, or the input power is not what you think it should be. One of the things we've done with the P&A recently, it's actually been since the inception, I should say, is it's fully calibrated from the factory. If you're at the test port, the power levels are within 1/4 of a dB. So you can connect your device, make all your measurements, set everything up before you start your initial calibration. And once you got everything looking about what you think it should look like, of course, the gain's going to be off by a dB if you have a dB loss of cable, but that's all right. Set everything up, get everything working the way you want. And then we have a capability we call Cal All that allows you to calibrate all your measurements and all your channels with just a single calibration. So the mistake people make, they start off calibrating instead of starting off measuring.
Interesting. Because I know my first trick would be to start calibration. So that's good feedback for me too. There's quite kind of a gray market or aftermarket for this old HP spectrum analyzer, or not spectrum analyzers, VNAs. If you look on eBay and try to land one, it's kind of a quite competitive right now to pick up an old one. How would people go about deciding whether they can pick up a VNA from the 90s or one that's a little more modern, assuming budget is,
So realistically, if all you're doing is making an S parameter measurement on a filter, using an 8409 from 1981 will do a very fine job. That was the first network analyzer I worked on as a summer student. I literally turned the crank. I ran the bolts and through the sides of the chassis to mount everything up. From the 8510 on, so that's 30 years ago, S parameter measurements haven't changed very much. But as soon as you get into any kind of complicated thing, you need to de-embed a fixture, you need to de-embed a probe, you need to calibrate for power as well as S parameters. None of that was in the older equipment. None of that's been in really since about 2007 is when we started to add all these capabilities like impedance transformation. If you're doing differential measurements, and the modern integrated circuits have all moved differential. And if you're measuring beyond S parameters, that's really the P&A and P&AX story, is taking your measurements beyond S parameters. If you're doing mixer measurements, if you're doing amplifiers and you need to have harmonic measurements, all of those things really point to the modern instruments. Further, I'd say if time is not your friend in your project, you don't want to spend a lot of time trying to figure out all the stuff that we've spent years figuring out. Just connect it up to P&A, make the measurement, the results will be right, they'll be fast. One of the first jobs I had was designing mixers for the 8753, and I wrote a program to run 2 sources in a spectrum analyzer, click, 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 making the mixer measurements. And maybe I could get a point a second, something like that. Currently, that's about what you're going to get even with our current sources and spectrum analyzers, maybe a bit faster. But that's really what started me on the take a network analyzer. I got one of our software firmware guys on the 8753 to do a little special bit of code that'll let the source and receiver track and offset frequencies. So I can make these really fast, 1,000 points a second measurements on a mixer that no one had ever done before. And that's what started off our whole generation of mixer measurements on network analyzers. You don't want to be writing. If you need to make an IMD measurement, you're going to have to get 2 sources. You're going to have to write some software to set the 2 source powers correctly. And then you're going to have to spend a couple days debugging that program because you can't figure out why source 2 frequency is always off a little bit. Or you could hook it up to P&A, push the button that says IMD measurements, and you got an IMD measurement.
That makes sense. Can you speak a little bit about differential and IQ measurements? Because I know that's been a new area that VNAs are looking at.
Yes. So we had again, this came directly from a customer request. We had one customer that said, I need to make a way of making harmonic measurements on a differential amplifier. So I have to take the two sources out of the network analyzer, have them 180 degrees apart, and then make the measurement at the second and third and fourth harmonic of the amplifier. So I have to hold the source's phase coherently and measure the receiver at different frequencies. We had nothing that could do that. About the same time, we had another customer that asked, I need to make the IQ a measurement on a single sideband mixer, an IQ mixer. And it's really wide band, so I need to have an I and Q signal, the inputs, need to be 90 degrees apart, and then I need to make receiver measurements at the plus and minus outputs, what we would call the out main and the image signal. So both of those requests came in at the same time. Both of these customers wanted to buy a few units, so it was a big deal. We didn't have enough resources to do custom apps for each of them. So we came up with the idea, and I was the lead on this project, of this application that allowed us to do frequency offset mode, receiver offset frequency, phase control sources. And that's what I thought we should call the application. But our marketing guy said, no, you have to call it after what it does. What does it do? And I said, well, it makes differential amplifier measurements and it makes IQ mixer measurements. And so they said, how about differential IQ? And for short, we call it DIQ. But it's really the Swiss Army knife of applications. You can do anything with it. You can sweep the power, sweep the phase, sweep the frequency, sweep them all at the same time and track any other receiver. So whenever someone comes to me with a problem of how do I make this odd measurement, I say, well, let's take a look if we can do it in DIQ.
That makes sense. That does seem more useful than a 1980s VNA for sure.
Definitely. You're not going to do that with your 8753.
So does your family find it interesting that you went from mixing as a family of bakers into mixers in the RF space?
My father was a baker, and during high school, my brother and I both did sports, and I wanted to do the after-school sports during wrestling season. So that was my turn to go work in the morning in the bakery every day, and he would work the afternoon shift. And my father would always tell us, make more money with your head than you do with your back, as we're toting the flour sacks around. So, no, my folks always intended all of us to go off to college. And I was a ham radio operator at 13 and taking bits and pieces apart of stuff at the house early on in age. So I think it was always a career path.
You had the knack from the get-go. And you got your PhD a little later than a lot of people do. Can you speak to how that came to be?
Okay, so I will tell you the story, and then you can decide whether it needs to be cut or not later. I was working on a new high-speed CPU for the 8753. This is around 1999, I think. And one of the things that you can do to test CPU speed is you have one channel of the analyzer test making frequency response measurements and one doing the time domain transform, which takes a lot of resources. And I had a filter on. I was kind of fooling around, and I noticed there was something odd that when I turned a screw in a certain place in the time domain, the signal went up in that spot. When I turned a screw on the filter in another spot, it went up and down. And over a few weeks' time, I figured out a way to tune filters entirely in the time domain. And I thought this would be a great application, and we looked about doing a software program from that, but we knew we had to have a good mathematical explanation of why that was. So I approached, we had a visiting professor at Keysight, Dr. Roger Pollard from University of Leeds. I said, hey, I'd be interested in doing a PhD program kind of associated with this. Would that be something that I could do? And he said, well, it's possible, we'll talk about it later. So went to my lab manager and I said, hey, would you sponsor me in a PhD program? He said, nah, not really interested. we went through reorganization about 2 weeks later, and another organization came and pulled me out. And just about the time that they were pulling me out into the new organization for some new things we were doing, the lab manager came back and said, "You can't pull him out. I promised him he could do his PhD at Leeds, so he has to stay in our lab." And the new organization said, "Oh, no, we'll sponsor the PhD as well." So that's how I got started.
Fascinating. It's funny how reorgs can lead to career opportunities. And
It always has in my case, very much so.
so what's your take on one company, especially, and I've kind of done something similar. I can't count how many managers I've had, but I mean, I could, but the concept of sticking with a company and bouncing around different roles and groups and divisions versus company hopping, which seems to be more common these days.
Yeah, I think if you recall, we were HP before we were Agilent, before we were Keysight, and we were a pretty big company. So if you hop from department to department, it would be very similar to company hopping now because things were so different. You could move from chemical analysis to medical to computers to RF and microwave. So you really could get exposed to a lot of different things. The other thing, and this is maybe being a little bit not humble enough, but Keysight and HP at the time really had the world's experts in everything we did. So you'd have a hard time finding another company that you're going to hop to where you're going to learn more than you can learn from the people inside of our company. So it's hard to think about moving to the lesser blue.
That makes sense.
We used to call it
The lesser blue.
HP used to be, IBM was the big blue and HP was the little blue, and then everything else was the lesser blue.
That's funny.
And one of the things I really enjoy about our new equipment is I can bring up a screen remotely and run the instrument just like I was at the front panel of the instrument. So I can control everything through the remote desktop. It's very convenient and allows me to do things like show this measurement I'm doing right now. So I've brought up my network analyzer. I sometimes use a spectrum analyzer, or I also have a spectrum analyzer here that I can look at. And I'm comparing now the phase noise measurements on the VNA with the phase noise measurements on our best spectrum analyzer. And this is measuring that little frequency converter that I sent you a video of. And we can see the phase noise measurements are, we see minus 84 dB on the UXA, that's the Premier Spectrum Analyzer. If I move my marker here to 10 kilohertz offset, I see about minus 85, 86 dB, so almost identical numbers in the measurements. But the nice thing I can do on the PNA is I can make the spectrum measurements looking at the output of the mixer. I can do the gain and group delay measurements, and I can even do the noise figure measurements, all from sitting where I am because I've connected this up. I can change parameters and do all the things I want to do. That's really the power of the PNA, is you can do everything you need to do with a single connection. And where that's really important, if you talk to the on-wafer guys, they hate touching their die more than one time with the probes. Every time you touch a die, you have a chance of scratching it. So having an ability to do a single touchdown and make all the measurements they want to make is something I find very powerful.
What do the spectrum analyzer, signal analyzer group think about this?
Oh, well, spectrum analyzers for analyzing spectrums, not components. The signal analyzers are for analyzing signals. So in the component test world, realistically, the modern VNA is the tool to use. And they'll be the first to tell you that their concentration is on doing 5G signal recognition and demodulation. The component test is not the main focus of those groups. So they would say we don't compete at all because we don't do signal analysis.
That's a nice happy way to work together.
I literally sit right next to the signal analysis team. So I have to be a little bit careful.
Fair enough. Yeah, I've taken some flack in my time as well. So I share that sentiment. Any parting advice for people who are looking to learn how to get into component testing and using VNAs and really getting better at the testing that they're doing today?
Let me think about that a little bit. I guess I will give you a bit of advice, and it has not to do just with testing, but I think everything in engineering. When you get a result that you don't expect, when you measure something and the amplifier gain isn't right, or there's a spur someplace, there's something that you don't expect. Stop there and understand what's going on. Make things simpler and simpler and simpler until you really do understand what's going on. And you'll find a lot of fundamental issues with your designs or your test setups that way. If an amplifier doesn't have the right gain, stop. Put a power meter on the source. What's coming out of the source? What's coming out of the amplifier? Did the bias of the amplifier happen? Is it oscillating and you don't know it? Really stop and make things simpler and simpler and simpler until you do understand it, and then layer back on the complexity to get to the final test you need.
That's a great philosophy.
Well, it's one that served me well. Simple is good for me. I can figure out what's going on. Once you figure out the basics, everything else falls into place.
Well, thank you so much for your time, and we really appreciate having you. It's been a pleasure talking with you.
Great. Thanks very much.
So how awesome is it to have Joel do an interview with us and be in chat and helping out? So I saw some great chatter there. A couple people had a common professor as Joel, so super cool. We are now at the point in the day where we get to announce today's winners. First, we will announce our SmartBench Essentials Challenge winner, and then we'll announce the Keysight University Live Sweepstakes winner. Each week, we're announcing a SmartBench Essentials Challenge winner. That's your chance to not leave your gear up to chance. You can submit an entry and tell us why you think you should win a set of SmartBench Essentials gear. That's a new power supply, oscilloscope, DMM, and function generator. Today's winning entry is Jack. And if we could pop up my screen, we have that winner entry up. The GU Rocketry team. Here's what the judges had to say about this entry. Jack's entry painted a riveting picture of the GU Rocketry project and the team's passion for space exploration and rocketry. He clearly described how Keysight's SmartBench Essentials equipment will enable them to gain hands-on engineering experience and real insights into their data while performing detailed analysis of hybrid engines. Keysight wishes Jack and the entire GU Rocketry team's success as they shoot for the stars. So congratulations, Jack and the GU Rocketry team. You won a whole set of Keysight equipment. And they're not the only ones who are winning gear. We have 5 people who have won their choice of one of those SmartBench Essentials gear, oscilloscope, power supply, function generator, DMM. Those winners are Simon Gan, Anas Hosso, Dylan Baxter, Vikram Singh, and Simon Quergfelder. Congratulations to those winners. We also have 3 U1282A handheld DMM winners, Dean Walwy, Peter Voss, and Tully Selingat. And our grand prize winner gets their choice of a whole set of different pieces of high-end gear, including a touchscreen 3000T like this, an electronic load, a couple other fantastic function generators, power supplies, DMMs. I think there's even an RF signal source in there. That winner is Gregory Schalander. Congratulations to all of our winners. And that ends our formal stream. Now we're going to go into some live Q&A. So put your questions in chat now. I have chat up here on my computer. And I've seen lots of folks pinging Joel as well. I pulled a couple questions from earlier on that Joel had answered. So I know the chat is not always available after the event. So I wanted to make sure some of those got through. One of the things Joel said is that you should think first, pre-measure, and then calibrate your VNA before going to do a full setup. And someone said, I didn't know that. I always calibrated my VNA first. And what Joel's response to that is that older analyzers didn't have a very good factory calibration, basically how they came out of the box without calibrating, because conventional wisdom says you should always calibrate your VNA before you do anything. And he says, older analyzers didn't have good factory cals. You didn't get a good result until after the calibration. New ones are pretty good, which means it's easier to set up and optimize your measurements before you actually go and make your calibration. So if you have a newer analyzer, you can go and hook up and make sure everything looks okay before you're doing your official formal measurement. Here's our little paperclip. I'm going to be careful with it. Paperclip antenna from the video today. That was a fun one. If you haven't checked it out, Smith charts, and then we checked out the RF performance of a paperclip. If you want more RF videos like this in the future, let us know in the comments on YouTube. Let us know in the chat here. We really want to make videos that are going to be helpful and educational for you, especially as I start to dig into more RF stuff. It's been a lot of fun for me. So if that's what you want to keep seeing, I'll keep making videos on it. Otherwise, I'll learn by myself in a vacuum. Someone asked about measuring the SNR, the signal to noise ratio of an antenna. And they said, can I basically measure SNR with a VNA? Joel said, you will also need a source to generate a reference signal for SNR, but you can measure it directly with the PNAX and the noise figure app. You can measure GT directly, which maps to signal to noise ratio. So yes, you can. You also need a good source, which makes sense if you're doing signal to noise ratio. You have an antenna. There are a couple other antenna questions out there. Someone asked, what are those boxes on the VNA? Can we pop up close? Someone made me some little 3D printed VNA boxes. I can share the STL on Twitter if you're interested, at Daniel Bogdanoff. These are actually PETG, so thanks to the folks that made these. They're just kind of fun little 3D prints. I figured it'd go well with the VNA. So that was answering that question. Lots of congrats to the winners and the model rocket team. What else? So they're small microwaves for tiny people. It does kind of look like that. They're asking about Joel Dunsmore's ham call sign. I don't know if he still does radio. Joel, if you're in the chat and are up for putting your call sign in chat, I'll re-announce it for folks who are joining after the fact. Other questions? This is a good one. Can you, on a VNA, using special setups, do things like oscilloscope art? So they're referring to people have made music where you put one channel into one side of the headphones and the other channel on the other side of your stereo mix, and you can actually draw pictures. You can't really do it. You could do maybe like a cityscape or someone mentioned in chat, something like that with a VNA. I have seen someone do pictures with a real-time signal analyzer. So they made like a Halloween jack-o'-lantern picture. So if you go digging on our social media, there is a way to do it with a signal analyzer. I haven't seen a way to do it with a VNA, mostly because it doesn't really do that RTSA type mode, or even an oscilloscope has that XY plotting. Maybe you could. I'd be very impressive. Okay, Joel's call sign was WA7ZWP, but it fell into disuse about the time his kids came along. So yeah, I understand that firsthand. Other VNA and questions for Joel, or about the video, just put them in chat. And we've been answering quite a few in the chat, so we won't dwell too long on the Q&A today. Is it possible to tune individual stages of radio receivers with the VNA? Yeah, doing impedance tuning and device tuning, a VNA is great for that, especially those interconnects. The trick is being able to actually get to the measurement points and doing the different stages, but I don't see any reason why you wouldn't be able to do that with a VNA. A couple folks talking about the nano VNA. I've been thinking about doing a nano VNA versus like an R&D grade VNA video at some point. So if that's a video you want to see, let me know in chat as well, because that could be super cool. We'll do one or two more questions and then call it a day. Lots of questions about calibration. So someone's referencing calibration kits. Joel says, if you add probes or fixtures after the cal plane, the calibration plane is basically you calibrate, and I mentioned it briefly in the video, you want to calibrate your VNA not just for your outputs, but for your whole measurement system up to your device under test. So your calibration plane is essentially calibrating everything up to the point of your DUT, and your calibration plane is there right before your DUT, so that you're only seeing the effects of your device under test and not like your cabling and your adapters and all that, because especially with like a 20 gigahertz or higher VNA like this, you're going to see effects from your adapters and from any cabling you add in place. That's why in the video today, the measuring a paperclip antenna, when I added my female-to-female adapter there, the Smith chart actually, you could see it going between open and short because the adapter was having some effect on the final measurement. Joel does say, though, that modern VNAs have a much better de-embedding function, so you can mitigate some of that. But when we talk about a calibration plane, that's what we're referring to. And then there's some fancy tricks you can do on top of that to get rid of those effects without having to calibrate. And that's really helpful if you have a complex setup. Maybe you can't go and calibrate and put your reference plane at the DUT every time. Or maybe you don't want to for some reason, for speed of testing or something like that. So there are some situations where you can de-embed those. Someone says, yes, I'd like to hear professional critique of the various nano VNAs. Yeah, I think the nano VNAs are really good. They're a really low barrier to entry way to get testing with RF equipment. So you can go play around with antennas, and you don't have to worry about blowing up a maybe multi tens of thousands of dollars type VNA. Those are $100, so a lot less risk and a really easy way to get your hands dirty. It is a lot more manual, a lot harder to use. Signals aren't the quality's not as good, of course, because it's $100. But yeah, I would definitely be interested in doing that video if that's something that you guys would like. We have Mark Hughes in chat. He won the first Smart Bench Essentials contest. Hey, Mark, shout out to you. Missed you last week. We'll do one more question. Let's see. Lots of questions rolling in. Joel's kind of parting advice here is simplify first, especially if you're having trouble here. Simplify first and figure out what's going on, and then layer on the complexity. So always definitely good advice to make sure. For me, when I'm doing RF testing, I'm a little green in RF still, but I'm learning, and I have some great help in the building here. But understanding every stage of my measurement, understanding how the measurement's made, what's happening, is so very, very important. And that's a big part of why this event exists and why our YouTube channel exists and why our blogs exist, is because we really want to help people understand what's happening inside the boxes, and they're not just looking at a squiggle on the screen and moving on to the next thing. So yes, a lot of people say they want the Nano VNA video. I'll do my best. It's not going to be this event, but probably this summer. Take some time and really make sure to do that video the right way. Yeah, the other question, would you consider cheapy VNAs from AliExpress, etc.? So Nano VNA is open source, so there are a lot of different options out there. I would recommend, I'm not officially endorsing any non-Keysight products, of course, but I would recommend trying to buy from the source and not one of the knockoff versions of the Nano VNA. It is open source, and they were okay with that happening, but buying directly from the source and from the designers helps support that project. So someone wants network analyzer phase noise measurements with Joel Dunsmore. I agree. Once COVID lightens up, we can hop on an airplane and go do some videos in Santa Rosa instead of here in Colorado Springs. They have all kinds of goodies over there. That's it for today. We're going to be back next Tuesday live from Colorado Springs at 10 a.m. Mountain Time. I'm Daniel Bogdanoff. Thank you so much for joining me, and I'll see you next week.